We're going to look at a Coulomb's law example that is a little bit more complex. It has 3 charges in it instead of just 2. So we have Q1, 2, and 3 shown there, and I've labeled them as 1, 2, and 3 just to make things a little bit simpler. And I want you to notice that we are going to be studying our 6 microcoulomb charge. So remember, whatever we do, we're going to be focusing on that 6 microcoulomb charge, also known as Q1. If we look at the 2 other charges, Q2 and Q3 are both going to exert forces on Q1. And so our strategy is going to be to look at each force separately and then combine them together. So let's just start by looking at Q1 and Q2. Now notice that Q1 and Q2 are the same sign. That means they are going to repel each other. And when they repel each other, I'm going to go ahead and just draw those out. And you're going to notice that our force on both Q1 and Q2 are pointed away from each other. Now remember, we're just studying Q1, so notice that that force travels or points to the left. So if I were to redraw Q1 right down here, right, so this is Q1, and I were to replicate that force and label it, I would call that force on object 1 due to 2. What that means is that that's the force on charge 1 caused by charge 2. Now we're going to use Coulomb's law, right, just like we did before. So we're going to use Coulomb's law, that guy right here, right, K times Q1 times Q2 over R squared, in order to find the size of that force. So what I would like you to do right now in that video is I would like you to find the size of the forces, or excuse me, this force, the force on 1 due to 2 using Coulomb's law. Note 2 things. This is in microcoulombs. Remember what microcoulombs means, times 10 to the negative 6. And then also remember that this is going to be, that distance is in centimeters, and that needs to be converted to meters. So what I'd like you to do now is pause the video, and then I'd like you to use Coulomb's law to figure out what is the force on object 1 due to 2. All right, you've taken a moment to do that, and you have put in those that equation, our Coulomb's constant, our 2 charges, and then our distance. Make sure that that distance between the 2 charges are squared, and we will see that we get a force with the size of 90 newtons. So take a moment, and hopefully that was comfortable for you. And what I'd like you to do is to go ahead and label that on your diagram as 90 newtons. Okay? All right, so then the next thing that we want to do is we want to look at the force that is acting, again, remember we're studying just Q1 here. We want to look at the force that's acting on Q1 that's caused by Q3, right? So we're looking at a different pair there. So on your picture that you've hopefully drawn in your notes, smiley face, I would like you to draw the forces that act on Q1 and Q3 on your picture. So take a moment and draw those forces in. All right, so the force that's acting on Q1 due to charge 3 here, or Q3, is going to be directed towards this charge right here, Q3, because they're opposite in charge, so they attract. And notice again, those 2 blue vectors, those 2 force vectors are the same size, opposite direction. And so since we're studying Q1, we draw that down here on our force diagram. And now we need to use Coulomb's law to find the size, right? So I would ask you again to pause the video and to use Coulomb's law to find the size of force 1, force on object 1 due to object 3. All right, we're back, and we are going to use Coulomb's law. So setting up Coulomb's law, I have my Coulomb's constant here. Again, I'm using that times 10 to the negative 6 since I have microcoulombs. Let's get rid of this business so we have a whole big screen. There we go. Sorry about that. And then we have our charge here. Now notice I didn't use that negative sign, right? We've talked about that before. This only tells us size but not direction. And when we put in the equation, that number, we don't put a sign of positive, negative. And notice this down here, this distance. I did have to add my 2 centimeters to my 3 centimeters because the distance between Q1 and Q3 is a total of 5 centimeters. So make sure that you use that distance of 5 centimeters. And then when you do that math, we get 43.2 newtons. So let's go ahead and take that and write that then on our diagram. So our force on 1 due to 3 is 43.2 newtons. All right, so the question asks us, what is the force that is on Q1 due to the other 2 charges, right? In doing that, we would need to look at our vectors. So we have 90 newtons pointed this way, right? And we have 43.2 newtons pointed this way. And we know, since those forces are in opposite directions, that they're going to have different signs. And that 90 newtons is negative since it's pointed to the left. So the force that is on object 1 will be the difference between our 90 and our 43.2 newtons. And so that would be 46.8 newtons. Now, if we really wanted to know a force in terms of direction, right? So that vector, what direction? We know that since the F12 is 90 and it's pointed to the left, it is negative. And so that's going to be bigger than that positive 43.2 newtons that's pointed to the right. And so our force that's on object 1 is a negative 46.8 newtons. Awesome. I hope this is helpful. Give those few questions a shot at the end of page 10 and on page 11. Let me know if you have any questions. Thanks.